Alright, let's solve another interesting physics problem. It was sent to me by my friend, and I'm trying to solve it for you, but then I suggest that you pause the video, read the question, and try to solve it on your own. Only then start to watch the solution. Okay. Assuming that you've already tried it on your own, let's see what the problem says. It says that a point object O is placed in a medium of refractive index mu1 1.4. S1 and S2 are two concentric spherical surfaces of variety 1m and 2m. To the right of O contains a medium of refractive index mu2, which is 1.5, between the interfaces S1 and S2. S1 and S2 are the two concentric spherical surfaces. Okay, find the object distance O from S1 so that the image O as seen by an observer from air coincides with O. See, the problem is that this question has not actually described properly what the setting is, but then we have an overall idea. So let's follow. We will start with again a straight line. In the straight line, let's say that there is a center of curvature C. There is some spherical surface here S1, and if this distance is 1 meter, then this distance is also going to be 1 meter, right? So this is S1 and this is S2. This is going to be medium 1, which is 1 point what? Let's see, 1.4, 1.5, 1.4 and 1.5. This is mid. This is 1.4. This is mu2, which is 1.5. This is, let's say, air, which is 1. Correct. So let's say there is an object O is placed. So whatever the distance is, if I do it like this, if this distance is x, whatever it is, x is going to be negative because the object distance is getting measured from the pole. This is the first pole, this is the second pole, right? If it is measured to the left, according to coordinate convention, it is going to be negative. So whatever the value is, we just assume it to be x. So this is the radius of curvature for the first one, that is 1 meter. But then since we are using coordinate convention, measuring the radius of curvature would take us to the left along the x. So it is going to be negative. Similarly, it is going to be -2 for the radius of curvature of S2, right? Remember it. So what really happens when someone sees this object? First of all, if assume that there is no S2, okay, only there is S1. So medium to mu2 continues or everywhere to the right. So there is a medium change from 1.4 to 1.5 here. So the image for this object would be formed somewhere around here. Okay, wherever it is. Okay, so wherever it is formed, this distance, let's say y. This is not the final image distance. This is the intermediate image distance of I dash. Okay, right. Then this I dash would act as an object when you take the refraction at S2. When you take the refraction as S2, you're gonna have to assume that to the left of S2, everywhere there is just mu2 is 1.5, and everywhere to the right is mu0 equals to 1. Correct. So now the object distance for S2 would be, like, you're gonna have to take care of the distance of I dash from P2, which is gonna be this distance is what, 1 meter, because the difference of radii between the S2 and S1 is 1 meter. But then since we're using coordinate convention and we're measuring to the left, so it's going to be y minus 1, correct, the object distance. So the image distance would be such that the final image is formed here exactly on O. So how do we do that? We use the spherical refraction formula, which is mu2 by v minus mu1 by u, which is mu2 minus mu1 by r, for a single spherical interface, right? It's the second medium, first medium, okay? And this is the image distance, object distance, radius of curvature. Using the sign convention at S1, let's say at S1, what will that be? If you use at S1, refraction at S1, will that be mu2, second medium? What is the second medium? Again, mu2. which is 1.5. 1.5 divided by V. What is the image distance, which is the intermittent image, right? That is minus Y, isn't it? Sorry, it's Y actually, because we, whatever the value is, image distance, we just take it as Y. So it's going to be Y minus, be careful and don't use the lens maker formula. Okay, so it's going to be 1.4 by, we take X, which is 1.5 minus 1.4 is 0.1. What is the radius of curvature for S1, which is 1, but taking sign convention, it's going to be minus 1. If we simplify this, it's going to be 1.5 by Y minus, okay, let's simply multiply 10 to the left and to the right. Right, so it's going to be 15 by Y minus 14 by X, which is 1 by minus 1, right? But then if we do the if we multiply minus 1 to the uh, multiply minus 1 to the left and to the right, it's going to be 14 by X minus 15 by Y is 1. That's our first equation, right? And the second equation, how do you find? Right, again use this formula, mu2, the second medium, that is air, right? If I do this, let's do that to the let's see, yeah, to left. Okay, in this for the second at S2, it's going to be mu2, which is air now, which is 1 divided by the image distance. The image distance, the image is where the actual object is. So the image distance when measured from P2 is going to be, so it's going to, this distance was X and this is 1. So taking while measuring along in agreement with the coordinates and convention, it's going to be minus 1 plus X. So it's going to be X minus 1, right? Minus, what is mu1? 1.5. The first medium is this here. You need to forget that there is any 1.4 present, because you are considering only the refraction between mu2 and mu0, right? Only S2 is there. Forget that there is any S1. So it's going to be 1.5 divided by u. What is the u? Object distance. What actually is the object in this case? The object is the intermittent image, correct? And its distance from P2 is going to be y minus 1. Minus 1 y plus y. Remember, it's y could be negative, okay? So it's y minus 1, right? And then that is going to be mu2 minus mu1, which is 1 minus 1.5, which is negative 0.5. So it's going to be 0.5 divided by the radius of curvature of S2 is 2 meter, but then using sign convention, it's going to be minus 2. It's going to be minus and minus. So in that case, if I separate everything like this, in that case, it's going to be 1 by x minus 1 minus 1.5 by y minus 1 is going to be 1. This is 1 by 2, minus minus cancels, so it's 1 by 2 is 1 by 4, correct? So what I'm gonna do, I'm gonna take it the 4 and multiply 4 on both sides, which is 4 by x minus 1 minus 6 by y minus 1 equals to 1. That's gonna be my second equation. So now look at the two equations, 1 and 2. How do we want to solve it? You can try to solve it, but here is my method. You just do it like that, like 14y minus 15x divided by xy is 1, right? So you can write it as 14y minus 15x is xy. Take that as equation 3. At the same time, how do we deal with this one? It's like, right, 4 times y minus 1 minus 6 times x minus 1 Similarly, it's going to be x minus 1 times y minus 1, right? So if you expand it, like 4y minus 4 minus 6x minus 6 minus 6x plus 6, sorry, is xy minus x minus y plus 1. So keep the xy here on the RHS, take the minus x to the left, and first take the minus y to the left. It will be 4y plus y, which is 5y, then minus 6x plus x, because minus x comes to the left, becomes minus 5x. Then minus 4 plus x is minus 4 plus x is plus 2, but then this plus 1 comes to the left, so plus 2 minus 1 is plus 2 minus 1 is plus 1, 0, correct? So let us make it oh, sorry, made a mistake. It's not 0, it's not 0. That's what you need to be very careful about, xy. So let's just say that this is the equation 2. No, sorry, it's equation 4, right? So now what do you do? Write down like this. For example, equation 3, let's subtract equation 3, so equation 4 from equation 3, equation 4, equation 3 minus equation 4. So just write 14y minus 15x equals to xy, and then minus 5y plus 5x minus 1 is xy. So now the result is going to be 9y minus 10x minus 1 equals to 0. So in this case, let's express y in terms of x. It's going to be 9y equals to 10x plus 1, isn't it? 10x plus 1. That implies y is 10x plus 1 by 9, correct? So this was plus 1. Uh, Let me check. 6 minus 4 is plus 2, plus 2 plus 1. Plus 1 getting subtracted, minus 1 was right. Correct. So far, so good. So why? Now, why do we want to do that? We want to solve this equation, right? So how do we solve it? Let's take the very simplest one. Okay. If you take the simplest one, for example, let's take this one, or let's just check this one. This appears to be very simple. 5y minus 5x plus 1 is xy. Okay, it's xy. So let's take care of this one. 5y minus 5x plus 1 is xy. 5y 5y minus 5x plus 1 is xy. So in this equation number 4, we substitute a value of x in terms of a value of y in terms of x. It's 5y minus 5x plus 1 is xy. 5y minus 5x plus 1 is xy. Let's just verify. Right, then put in the value of y obtained here. Let us call that equation what? Which equation do we call it for? We'll call it equation 5. Okay, it's okay not to even label it, but fine. All right, so it's we just have to put in the values of y in this equation. So 5 times 10x plus 1 by 9 minus 5x plus 1 is x times 10 plus 1 by 9. Savvy? So just open the bracket. It's going to be 50x plus 5 by 9 minus, I can write 5x as 45x by 9 plus, I can write it as 9 by 9 as it will be 10x squared plus x by 9. So see, you can easily cancel the 9s in all the denominators. or just multiply 9 to both sides. So it's going to be 50x plus 5 minus 45x plus 9 is 10 squared plus x, correct? So why don't we just take all these terms to the right side and then invert it, like exchange the sides, okay? So it's going to be 10x squared plus x as it is, then all of these terms will be negative. So minus 50x minus 5 plus 45x minus 0. So in this case, it's going to be 10x squared. So all the x terms, x minus 50 plus 45. What is that? Minus 50 plus 45 is minus 5, right? Minus 5. But then plus x is going to be minus 4x. Minus 4x. Minus 5 and minus 9. That would make like minus 14. 0. This is a quadratic equation. Formula for it is x is negative b, which is minus 4. Minus 4 is 4 plus or minus square root of discriminant is going to be b squared, which is minus 4 squared is 16 minus minus 4 times 10 for AC, 10 times minus 14 divided by 2a. A is 10 again, so 2a, right? Simple. 4 plus or minus, oh, this is 20, okay, 20. So square root of, what is that? 16 minus minus plus, minus times minus plus. So it is going to be 4 into 10 is 40, 40 into 14 is what? 14, 4, 6, 560, right? So it's going to be 560 by 20. 16 plus 5 is 576. If you take the square root of it, I think it's going to be 24, correct? So it's going to be 4 plus or minus what? 24 by 20. So if you take the positive sign, x becomes positive, right? If you take the positive sign, x becomes x plus 24 by 20, which is like 28 by 20. It's going to be 28 by 20. So whatever that is, it's a positive value. We know x is negative because the object is here. Like this is the object and this is the S1 surface. So here to here, when you from 4P1, if you measure, you go to the left, and that gives you a negative x, negative object distance. So this is not correct. The other option has to be correct. So x has to be 4 minus 24 by 20. It's going to be 4 minus 24 is minus 20 by 20. It's minus 1. So it's minus 1 meter. Basically, the object distance is 1 meter, but when you mention it with the proper sign convention, you're gonna have to have x equals to minus 1 meter, right? So you should better write x equals to minus 1 meter using the coordinate sign convention. So what is it asking? Find the object distance so from the s1 in meter, so that okay, it's not asking in the direction, so you need to mention the minus 1. So it's going to be minus 1 meter. Okay, I think that should be the answer, proper answer, and see you in the next problem.